So in the previous lecture, we saw that there is no rational number whose square is 2. So there is certainly, you know, you have a real number system, and there is a rational number set system which is a part of the real number system, and then real number system is a part of complex number system. This algebraic structure was there in rational numbers, was there in real numbers, and is also there in complex numbers. So we want to know what is the difference between these three structures. You have rational numbers is also a field, reals is also a field, and complex numbers is also a field. So the question is there any difference between these three? So we'll first answer it by actually talking about the difference which is there between real numbers and complex numbers, and that difference is of order structure. When we have two real numbers, we can compare them, whereas when we have two complex numbers, we cannot compare. We can compare which real number out of the two is greater, but this cannot happen in complex number. So this is known as order properties of R. And for this, what we do is we first define a set, a non-empty subset P of R, and we call it, so we say there is a non-empty subset P of R called the set of all positive real numbers, such that, so what is the speciality about elements of this set? The speciality is if A and B are two elements of this set, then the sum of these two elements, we have already defined sum as a binary operation, then the sum of these two elements is also in P. The second property is if A and B are elements of P, then their product, again the binary operation we already know, is also in P. So now we know that in positive numbers also, if you have two positive real numbers, then their sum is a positive real number. So this is matching what the notion of positive numbers that we have, right? But in a way, this is the origin of the positive numbers. हम ये मान के चल रहे हैं there was no real number system that we knew. Now in a way we have defined real number system, we defined plus on real number system, we defined dot, studied some properties. Now we are taking a subset of real numbers, calling it P, the set of positive real numbers, which satisfies some properties which are very special. So not all real numbers satisfy this. For example, if you have two real numbers like -2 and 3, then their product, which is -6, is not in P, right? So not all real numbers satisfy this property, but if those real numbers who satisfy all these properties that I am writing are elements of a set which is called set of all positive real numbers. Then the third property says if you have any element of P, then exactly one of the following holds. And what is that? That means there are three things, but only one will hold at a time. Either A belongs to P, or A will be 0, or the additive inverse of A will belong to P. So in a way, if we collect all the additive inverses of the elements of P, then we are saying that either A will be in P or its additive inverse will be. So this set and the set of all positive numbers, which is A belonging to P, have nothing in common, right? So this is in a way we are saying if you have any real number, not positive real number, if you have any real number, then exactly one of these things should hold, and that means if you have a real number a, then it has three possibilities: either a belongs to p, or a is 0, or minus a belongs to p. That means we have divided R in three parts: the set of all positive real numbers, 0, and the set of all additive inverse of the positive real numbers, which we call, so this set, the set of all additive inverse of positive real numbers, is called the set of negative real numbers. So real line has been divided in three parts: positive, 0, and negative real numbers. So that is why this law is called tri for three parts. So this is called trichotomy, law of trichotomy or trichotomy property. We will come back to this another form of this property in a short while. So one thing we must note here, that if A belongs to P, A is called strictly positive. If A belongs to P union 0, A is called non-negative. Thirdly, if minus A belongs to P, A is called strictly negative. And then if minus A belongs to P union 0, then A is called non-positive. Now this is fine. We have the set of all positive numbers, but we have still not talked about the order. Order means if you have some real numbers, then can I arrange them in increasing order or decreasing order? Or if I have two real numbers, can I talk about A is greater or B is greater? So you have that sign called greater than sign that we will define now. So if you have two real numbers A and B, then we say if A minus B, so we know either A minus B is in P, or A minus B is 0, or A minus B, the negative of that is in P. So if A minus B is in P, then we define A to be greater than B. ये हमारी definition है. Or we can say B is less than A. Similarly, if A minus B belongs to P union 0, then A is greater than equal to B, or B is less than equal to A. So we have in a way defined the less than and greater than sign. And keeping this in mind, we can actually now talk about another form of law of trichotomy, or which we called trichotomy property earlier. As I said, we will come back to it. So this another form is that, see, if A and B are two real numbers, then A minus B is also a real number, and as per the trichotomy law or property, we have either A minus B belongs to P, or A minus B is 0 because this is a real number, or the additive inverse of A minus B is in P. That means now A minus B is in P means that A is greater than B. So either exactly one of these has to hold. So either A is greater than P, or A minus B 0 means A is equal to B, and minus A minus B belongs to P means A is greater than B. So minus A minus B belongs to P means What was the definition of the additive inverse belonging to P? So we can say B minus A belongs to P, which means B is greater than. So now again we have divided, we have set three conditions for comparing two real numbers. Either A is greater than B, or A is equal to B, or A is less than B. So this is also known as law of trichotomy. So let us do a small result which will give us some powerful tools of order properties. So the result that I am going to talk about here is that suppose you have three real numbers and then there are three properties that we will prove. First property is that if A is greater than B and B is greater than C, then what should be the relation between A and C? And we know A should be greater than C. This property is known as transitivity, right? And we will prove this property. Second is if A is greater than B, then A plus C is greater than B plus C. So C can be negative, C can be positive, but A plus C will always be greater than B plus C. This is monotone law of addition. Similarly, we have a law for multiplication which says if A is greater than B, but of course there is a condition here, if A is greater than B and C is greater than 0, then A into C will be greater than B into C. And if A is greater than B and C is less than 0, then A into C will be less than B into C. And this is called monotone law of multiplication. So let us see what is the proof of this first part, which is transitivity. And in this we have to prove that if A is greater than B and B is greater than C, we have to show A greater than C, right? Now this is given to us. Now we have defined already that A greater than B means A minus B belongs to P. B greater than C means B minus C belongs to P. And when we define the order properties of the set P, then we said if two numbers are in P, so this number and this number both are in P, then their sum is also in P. That means A minus B plus B minus C will also be in P, which means A plus minus B plus B. So this is associativity. Plus minus C belongs to P. So we have changed the brackets using associative law. But minus B plus B is 0, so this becomes A plus 0, which is A, because 0 is the additive identity. A plus minus C is simply A minus C, so A minus B belongs to P. And A minus C belongs to P means A greater than C. So this is what was to be proved, and we have shown that if A is greater than B, B is greater than C, then A is greater than C, transitivity. Now we come to the second part. In second part, we have to show if A is greater than B, then A plus C is greater than B plus C. So it is given A is greater than B, and we have to show A plus C is greater than B plus C. Please note here, we are not saying what is the sign of C. We are not saying whether C is positive or negative. C kuch bhi ho, A plus C will be greater than B plus C. So if A is greater than B, this means A minus B belongs to P. This is the definition of A greater than B, which means A plus 0 minus p belongs to p. Now you will think why I am introducing 0. Let us see what we have to show. We have to show a plus c greater than b plus c. So ये जो आइडिया ज़ीरो का है वो यहाँ से आया कि हमें पहुँचना कहाँ है. अगर हमें प्रूव करना है a प्लस सी ग्रेटर दैन b प्लस सी, दिस विल फॉलो इफ़ a प्लस सी माइनस b प्लस सी बिलोंग्स टू p. So rearranging the terms by commutativity. So first of all, if you look at this, a plus c minus c plus b belongs to p, right? Or by associativity we rearrange the terms, a plus c plus minus c plus minus b belongs to p, right? But c plus minus c is what? C plus minus c is 0. So that is why we introduce this 0 and then we replace 0 by c plus minus c in the next step. And see, now all the steps have already been rough work has already been done. तो अब हम पहले हमने उल्टा चला कि हमें जाना कहाँ से है, कहाँ पहुँचना है, फिर उल्टे उल्टे चलते गए, बट अल्टीमेटली यही हमें वहाँ ले गया और हम जब अब सही सीधे डायरेक्शन में चले तो यहीं पहुँच गए जहाँ जाना. सो इस तरह से हमें आइडिया मिल जाता है कि हमें कहाँ पहुँचना है, उसी से हम प्रूफ बनाते हैं. कमिंग टू द थर्ड पार्ट, एंड रिमेंबर दिस इज़ कॉल्ड मोनोटोन लॉ ऑफ एडिशन कि अगर a ग्रेटर दैन b है तो a प्लस सी इज़ ग्रेटर दैन b प्लस सी. इसको हम बार बार यूज़ करेंगे. अब हम आते हैं थर्ड पार्ट में, जिसमें अगर a ग्रेटर दैन b है और c ग्रेटर दैन 0 है एंड वी हैव टू शो AC greater than BC. So if we have to show, so let us try the same way, उल्टा चलने के तरह कि हमें जाना कहाँ है. हमें दिखाना है AC should be greater than BC, right? That means we have to show AC minus BC should be in P. That is, if we look at distributivity, A minus B into C should be in P, right? अब जो गिवन है उस पर आ जाते हैं. A greater than B मतलब A minus B belongs to P, और C is already greater than 0 means C belongs to P. और P की प्रॉपर्टी है कि अगर दो नंबर्स P में हैं तो उनका प्रोडक्ट भी P में है. So that means A minus B into C belongs to P, which now by distributivity, so now we get AC minus BC belongs to P, which implies AC greater than BC. सो रिमेंबर P का जो हमारा सेट था उसकी जो प्रॉपर्टीज़ हैं वो हम बार बार यूज़ कर रहे हैं. और उसकी प्रॉपर्टीज़ क्या थी? उसकी प्रॉपर्टीज़ थी कि अगर A और B P में है, ये मैं बीच में याद दिला देती हूँ, तो A प्लस B भी P में होगा, A इंटू B भी P में होगा. और फिर ट्राइकॉटमी वाला लॉ था जिसमें हमने कहा था कोई भी रियल नंबर जो होगा वो तो या खुद P में होगा या वो 0 होगा या फिर उसका एडिटिव इन्वर्स P में. तो ये प्रॉपर्टीज़ हम P की बार बार यूज़ कर रहे हैं. इसी थर्ड का दूसरा पार्ट है A ग्रेटर दैन B, C लेस दैन 0. तो आई गिव यू दिस पार्ट एज एन एक्सरसाइज. इसमें आपका नेक्स्ट स्टेप होगा माइनस C ग्रेटर दैन 0. और फिर अब आप ऊपर वाले स्टेप्स रिपीट करके यू विल कम टू द पार्ट वेयर यू विल गेट AC लेस दैन BC. सो प्लीज़ कंप्लीट दिस पार्ट. And with this we come to the next very important result, which is going to tell us a thing that which you already use. One is a positive real number, but for this we have to do some homework. First part, we will show that if A is any real number and it is not 0, then A square should be positive. And using this we will show that 1 is positive, and then using 1 positive we will show that if n is any natural number, we have already defined natural numbers as repeated sum of 1. 1 plus 1 plus 1 n times gives us n. So अगर n कोई natural number है तो हम ये भी prove करेंगे that n is positive. So for the proof, for the first part, okay, let us prove the first part. Now if A is a real number, A is not 0, that is already given. So we have two possibilities, either A is positive or A is negative. In both these cases we will get A square is greater than 0. Now if A is positive, then we have already now देखो, एक तो हम कह सकते हैं A greater than 0 means A belongs to P, फिर A into A belongs to P, बट अब A belongs to P या A greater than 0 को हम सेम मान के चलेंगे, P को अब लाने की ज़रूरत नहीं है, उसको छोड़ देते हैं। तो A greater than 0 मतलब A into A भी पॉजिटिव है, विच मीन्स A square इज़ पॉजिटिव। अब आते हैं केस पे जब A लेस दैन 0 है। A लेस दैन 0 मतलब माइनस A लेस दैन 0, which means minus A into minus A is less than 0. And now though I am saying minus A is greater than 0, right? And which means if minus A is greater than 0, then minus A times minus A is greater than 0. So minus A times minus A is A square. अब ये जो स्टेप है ना, माइनस ए इंटू माइनस ए इज़ ए स्क्वायर, इसके लिए हमें थोड़ा सा होमवर्क करना पड़ेगा, पर ये हम अभी मान के चलते हैं। इसको मैं अब एज अ रिज़ल्ट यहाँ पर या एज अ रिमार्क आपको एक प्रूव करके दिखाऊंगी कि माइनस ए इंटू माइनस ए इज़ ए स्क्वायर। तो अभी मान के चलें तो वी गेट ए स्क्वायर इज़ पॉजिटिव। सो इन बोथ केसेस वी गेट दिस, सो वी गेट hence a square is positive if A is not 0. अब ये शो करने के लिए कि माइनस ए इंटू माइनस ए इज़ ए स्क्वायर, हम सबसे पहले इसको दो पार्ट्स में प्रूव करेंगे। सो लेट अस राइट इट एज रिमार्क्स 1। सबसे पहले हम प्रूव करेंगे कि माइनस 1 इंटू ए इज़ एडिटिव इन्वर्स ऑफ ए, जो कि चीज़ हम बहुत बार यूज़ करते हैं। माइनस 1 इंटू ए माइनस ए होता है, तो ये कैसे होता है माइनस ए? माइनस ए मतलब एडिटिव इन्वर्स ऑफ ए, और एडिटिव इन्वर्स यूनिक होता है। तो हमने कहा अगर कोई भी बी ऐसा है जो कि ए प्लस बी को ज़ीरो कर दे, तो बी क्या होगा? एडिटिव इन्वर्स ऑफ ए, ये हमें पता है। तो हम दिखाएंगे कि ए प्लस माइनस 1 इंटू ए गिव्स अस 0, ठीक है। सो कंसिडर करो इसको, ए प्लस माइनस 1 इंटू ए, this is a into or 1 into a plus minus 1 into a, which is equal to 1 plus minus 1 into a, but 1 plus minus 1 is 0, so this becomes 0 into a, so we get 0. So we get a plus minus 1 into a is 0, which means that minus 1 into a is additive inverse of a. तो जितना ये भाषा यूज़ करोगे माइनस ए की बजाय एडिटिव इन्वर्स ऑफ ए, तो समझ आएगा हम क्या कहना चाह रहे हैं। तो माइनस 1 इंटू ए इज़ माइनस ए, पहली चीज़ ये हमें मिली। सेकेंडली अगर हम अब माइनस ए इंटू माइनस ए करें, तो वो अब हमने इसका मतलब माइनस 1 इंटू ए इंटू माइनस 1 इंटू ए, फिर एसोसिएटिविटी लगाई तो हमें मिला minus 1 rather we can actually, because to avoid some steps we can just use commutativity and associativity all in one step and write it as minus 1 into minus 1 into a square, and minus 1 into minus 1 again will be additive inverse of माइनस 1। क्यों? क्योंकि हमने अभी बोला है माइनस 1 इंटू एनी नंबर थीटा इज़ एडिटिव इन्वर्स ऑफ थीटा, तो यहाँ थीटा हमारा हो गया माइनस 1। सो माइनस 1 इंटू माइनस 1 इज़ एडिटिव इन्वर्स ऑफ माइनस 1, राइट, इंटू ए स्क्वायर। एंड नाउ माइनस ऑफ माइनस 1 मीन्स एडिटिव इन्वर्स ऑफ माइनस 1 विच इज़ 1, right? So additive inverse of minus 1 is 1, so you get 1 into a square, which is a square. So look at this, this is what we have proved, that minus a into minus a is a square, जिसको हमने यहाँ पर यूज़ किया। फाइन, सो दिस completes the first part कि अगर a नॉन ज़ीरो है तो a will be strictly greater than 0. Then we come to the second part of the proof. बीच में हमने जो ये 1 और 2 लिखा है ये रिमार्क्स थे, अब हम वापस थ्योरम के प्रूफ पे आ गए हैं। और सेकेंड पार्ट ऑफ द प्रूफ में हमें प्रूफ करना है 1 इज़ ग्रेटर दैन 0. So do you agree that 1 is not 0? Now how is 1 not 0? Because suppose 1 is equal to 0 और मान लो a कोई भी नॉन ज़ीरो रियल नंबर है. तो अगर a नॉन ज़ीरो रियल नंबर है तो a into 1 will be a into 0 which is 0 because we have proved that any number into 0 is 0. So you get a into 1 is 0 but 1 तो मल्टीप्लिकेटिव आइडेंटिटी है, a इंटू 1 तो a होता है. तो हमारे को इन दोनों ऊपर की स्टेटमेंट से मिल गया a इक्वल टू 0 विच इज़ अ कॉन्ट्रडिक्शन टू द फैक्ट दैट a इज़ नॉट 0 विच इज़ नॉट ट्रू. राइट. So that means the assumption that we made that 1 is 0 is incorrect and therefore 1 is not 0. So as 1 is not 0, by previous part 1 square must be positive, but what is 1 square? 1 square is 1 into 1 which is 1 which is greater than 0. So this proves that 1 is a positive real number. Coming to the third part, we have to show any natural number n is positive. We use mathematical induction. Now what is mathematical induction? Let us see here. In mathematical induction we have some statement which depends on a natural number n. So what we do is we prove that and we have to show that this statement is true for all n. तो हम क्या करते हैं, हम शो करते हैं कि वो स्टेटमेंट n इक्वल टू 1 यानी S1 ट्रू है. और फिर हम कहते हैं कि मान लो जब भी किसी नेचुरल नंबर k के लिए Sk ट्रू होगा तो Sk प्लस 1 भी. सो Sk अगर ट्रू है याद रखो तब Sk प्लस 1 भी ट्रू होगा. ये हम प्रूव करेंगे. तो इससे क्या होगा, 1 के लिए हम शो कर चुके हैं तो 1 के लिए ट्रू है तो यानी 1 प्लस 1 यानी 2 के लिए ट्रू. राइट. अब S2 ट्रू हो गया तो S2 प्लस 1 यानी S3 इज़ ट्रू. सो करते करते ये स्टेटमेंट जो है Sn इज़ ट्रू फॉर ऑल. तो ये मैथमेटिकल इंडक्शन का मेथड है. तो हम ये इंडक्शन यहाँ पे लगाएंगे. हमें प्रूव करना है स्टेटमेंट क्या है, S क्या है, n इज़ ग्रेटर दैन 0 फॉर एवरी नेचुरल नंबर n. तो पहले फॉर n इक्वल टू 1 इज़ ग्रेटर दैन 0 अभी हमने सेकेंड पार्ट में प्रूव किया है. सो इस स्टेटमेंट को अगर 1 नंबर कर दें रोमन 1 तो 1 इज़ ट्रू फॉर n इक्वल टू 1 and then we say let 1 be true for n equal to k. इसका मतलब है k is greater than 0. अब हमें प्रूफ क्या करना है, k प्लस 1 ग्रेटर दैन 0 और ये आ गया तो हमारे पास आ जाएगा 1 is true for n equal to k प्लस 1 और हम कह देंगे by induction 1 is true for every natural number n. तो अब कैसे पहुँचेंगे यहाँ पर अब हम देखते हैं. k पॉजिटिव है और 1 पॉजिटिव है और हमें पता है p की जो प्रॉपर्टी है उससे कि अगर दो नंबर्स पॉजिटिव हैं तो उसका सम भी पॉजिटिव है. सो वी गेट k प्लस 1 इज़ पॉजिटिव. सो दिस इज़ अवर these are important results because these form the basis of these number systems that we have been studying. So I stop here and then we'll move on to some more properties in the next lecture.